All right, so I want to make sure that you guys know how to export, more importantly, how to import the data and use it in your lab. So here's a lab. This is the pH lab actually, and the exporting is pretty simple. You click on the three lines and you go to export data, and the file format that's best is the CSV. So I've already exported this data as part C group 2, so I'm not going to do it again. Once you've exported the data, then for you to get to level 4, you actually have to create the data in the graph yourself. You have to create the graph yourself. So in Excel, I go to File, Open, Part C, Group 2, that's my data. So wherever you saved it on the computer. Now what I'm going to do is I'm going to help you import the data and graph this data. So this data, it so happens that all the runs here, they're all valid. But in your cases, you guys might have had one or two runs that didn't work. So you might need to delete them. So taking a look at the screen here, I'm just going to make this a little bit bigger so you can see it. This is date and time for run 1, and this is date and time for run 2, run 3, run 4, 5, 6, 7. Okay. This column here that's a date and time, that's irrelevant. We don't need that. When I was running this lab with this particular group, I forgot to change my sampling time from 20 hertz down to 1 hertz, so I actually have a lot of data. Now, the first thing I'm going to do is I'm going to insert a new row, and I'm going to label the data. So this here is pH2. This here is pH4, pH6, pH7, pH9, pH11, and pH13. So that's all our data. I'm going to get rid of these columns here by selecting A. I want to get rid of D. I'm holding the control button on my keyboard so I can multiple select G, J, M, P, and S. And I'm going to right click and delete those cells. So they're all gone. All right. Now, in terms of my time and pressure, these are all time. Right now it kind of says it's time run 1 and this says time run 2. I don't need that information. I just need time and pressure. I want them all to be the same title so that way it'll graph properly. So I'm going to call this time. I'm going to copy that cell, paste, 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 paste. And the same thing here with pressure. So I'm going to type in pressure as my new title, copy, paste, 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 paste. Right, so I got time and pressure for each of these runs, for pH2 all the way up to whatchamacallit. Now, in terms of time, the time is the same. So this time is going to represent my y-axis, and the pressure, which is the dependent variable, is going to represent the other axes. So the time is always the same. So I actually don't need the time for the other runs. So I'm going to hide them. So C, E, G, I, K, K, and M, I don't need those, so I'm going to hide those. Right click, select hide. So now all gone. So now I have the same A, independent variable, and then all these are dependent on the time. So now I highlight every single one. I go over to insert. I select the scatter plot because we're looking at the relationship between two variables, so not a line graph, which many of you are tempted to do. I like to do the dots. I don't like the line because I want my own line of best fit. So I'm going to do this one over here. And there's my chart. Like I said, I have a lot of data. Now, because I didn't change my data point, these numbers here, they're actually representing hertz. So this is 2,500 hertz. So if I wanted to know what that is in seconds, so I can leave it in this variable, it's perfectly fine, because it's basically 20 measurements per second. I can come over to here and just stick in my calculator, right? So 2,500 divided by 20, it gives me 125. Which is about what we ran it for. We ran them for about 2 minutes. Okay. So there is my data table. But now I probably want to change things up here because these first few seconds here, they're really not that important. So, but these spikes here, they kind of are. So it would have been really nice when I was running this lab if I could have actually done it in such a way that they all flipped at the same point. That would have been perfect, but I wasn't that good. Now for any one of these lines, I can select it and then I can add a trend line, right? So I can right click on this, add a trend line, and it'll give you a bunch of options. I mean, for the most part, it looks like a relatively straightforward curve here. So here's a linear relationship, right? So I can get that trend line. I can display the equation on the chart. I can move my equation so I can actually see it. So the slope is 0.0021, right? That's my M. I can come up to this one here, select it, right click, add my trend line. I want my equation again. And so the slope of this one here is 0.0183. So look, I got these slopes. I'll go up to one of these tall ones up here, pH of 6 or 7. I think that's 7. Add my trend line and display my equation on my chart. So this is 0.0511. So if this slope is representative of this line, then we're great. Now when you look at this data here, this line of best fit here doesn't best approximate the data. This is the part that you'll have to decide. You do want to use the same kind of trend line for each of your graphs that you're trying to interpret. But when you look at your different types of trend lines you can have, linear typically represents a linear relationship. Logarithmic represents, high at the beginning and kind of plateauing at the end, and polynomial, and so on and so on. So this linear line of best fit might not be the best choice. Maybe I should be using a logarithmic. So I leave that to you to decide what is the best line of best fit. Okay, that's something that you will have to decide. And once you make that decision, then you can pick out your slope and compare those values. All right, but that's a decision that you're making. The other option you have on here is you can change the range. So right now I'm going from 0 to 2500. So I'm going for all these lines of best fits, they're including a period of time that's 0. So maybe if I put them all in the same chart like this, this allows me to compare the maximum amount of gas that was produced over a period of time, which is great. But let's say I just want to find out the line of best fit for each particular line. For that, I might be better graphing each individual line and then removing the 0 portion. And then whenever the gas was released, using from here, let's say, from this point to the end to represent my line of best fit. And from this point to the end to represent my line of best fit. For this gray one here, it's going to be, instead of at 20 seconds, it might be at 10 seconds. Right, so that's stuff that you'll have to kind of play with in order to get the lines that best approximate the data. All right, so that is how we do import the data, how you can create a graph, a multiple graph. That's how you can get your line of best fits as well. And you should be incorporating that into your graph. Now you'll notice on the website, I've given you a template, right? I've tried to make these things as easy as possible for you, especially those in grade 11, we didn't do any real labs that are written up like this. So I've given you a template. And if you take a look at that template, what you'll see is that I've organized it based on the lab format. So I'm just pulling out the template here. I have several templates. I think the template I put up on the website actually has some results already. So they're from a previous year, they're from last year. So that gives you something to compare your data against. So taking a look at this template, right, make it bigger here. So I'll give you a table of contents, which is, that helps with communication. It's not necessary, but it's better communication. Your introduction, I tell you what's supposed to go in the introduction, your purpose, right? And your hypotheses, which you already submitted, but you can resubmit in this lab as well. But I wanted you to actually think about what you thought was going to happen in the lab, and then show me. Then we have your hypothesis for each section. At the minimum, you did A, and then your choice, B, C, D, or E, whichever was assigned to you. You might have done a hypothesis for all of them, depending on the situation. Procedure, do not copy out the procedure. The procedure is already given to you. In real lab reports, you don't repeat procedures that are given to you. You just say, refer to lab manual, refer to lab instructions. The only procedural things you put in are procedures that are different from the main instructions. So if I told you to use 6 mils, if I used 5 mils, then you'd say that. Observations, The observations are both quantitative, so the actual numbers, and qualitative, what you observe, the colors, the odors, the sounds, and things like that. Transparency, clarity. Analysis are your graphs, and a very short blurb about each graph, very, very short. The analysis can be broken up by each experiment. So even though you only did part A and your part, if all you report on is your part A, which everyone did, and the part that was assigned to you, the maximum level that you can get is a 4 minus. That's a maximum level if you get everything else perfect. If you're aiming for anything higher than a 4 minus, anything higher than an 80%, then you must include the other lab sections. All right, so even though you only did 2 lab sections, in order to get to the highest level, you must include stuff about the other 5 sections. Excuse me, please. All right. Then the interpretation. So the interpretation includes several sections. The interpretation includes your sources of error, and as I was talking with the group that I was working with, I kept on mentioning different sources of error that could happen. The discs and the amount of extract you put on each disc could vary. The fact that you're holding the bottle with your hand versus leaving it on the desk, your body temperature could change the pressure. You could have it denatured, decomposing. The stuff you did at 8:45 versus the stuff you did at 10:30. There's a 2-hour window where the liver extract might have decomposed even though it was on ice. There's lots of different types of errors. The most important section, and this is the section that really decides for most people what level you're going to get, because everything else is pretty self-explanatory, is the theory. You need to make connections between this lab and the theory we talked about in biochemistry, and to a lesser extent in metabolism, because we talked a little bit about enzymes on the first lesson of metabolism. So this is the most important section. You're going to include things like the particle theory, the kinetic molecular theory, things that we learned in chemistry, explaining why when you have more substrate, there is a greater rate of reaction. When you have a metal salt, why there's less rate of reaction. When you increase the temperature, why there's a greater rate of reaction until you get to a certain temperature. All those sorts of things. That's in the theory. And if you're organizing this well, you're probably going to divide it into the various different experiments. Remember, if all you do is focus on your 2 sections, part A and whatever's assigned, the maximum mark you can get is an 80. And it's more doable. That's a more reasonable amount of work. If you are aiming for something higher, then you must do all the sections. But just because you do all the sections doesn't mean you get an 85. It's not automatic. It still has to be accurate. Okay? All right. And then I gave you some questions here. If you decide to incorporate these questions in your interpretation, it's not question and answer. You don't answer the question and then put it off as its own single sentence. You incorporate that into your discussion. So in your interpretation, you answer these questions as appropriate. Other subsections of the interpretation include your procedure. Did the procedure work out nicely? Was it great? Or do you need to revise something? That's what the evaluation of the procedure is. Evaluation of the procedure and strengths and limitations are very similar. I would choose one or the other. I won't do both. Revisiting the hypothesis. So was your hypothesis accurate? Some labs, you'll see that they do this in the conclusion, but technically you're not supposed to do that there. You're supposed to do that in the interpretation, especially when you get into university. And then finally, your conclusion is a single statement. In this case, figure out a statement that kind of encompasses all the various parts into a statement. This conclusion will be longer than your typical conclusion because there's so much happening. Your appendix. Now, if I was in group 3, and I did part A and part C, then the data that I collected go in my observations. But because I'm reporting on all 4 sections, A, B, C, D, and E, and I didn't do 3 of the sections, I don't include that data in my observations because I did not observe it. But because I'm reporting on it, I should include it in my lab. And so I include that data in the appendix. What you'll see here is I've actually included all data using low-tech technique, I believe, in the appendix. So you would erase this if you're not using it, and you'd incorporate the data from the class. So hopefully all the groups have uploaded their data to the shared Google Drive, and you'll have access to that. All right, but anyway, so that's the other results. You put them in the appendix. Also diagrams. If you had like a picture that showed the tertiary structure of catalase, or you're trying to explain something and it was a really good picture, then you put that in the appendix. Typically anything that's going to ruin the flow of your lab, you put in the appendix, but it will support the lab. Okay, so that's all here. And of course your reference bibliography, You are going to have sources that you're going to get your information from. This is going to Turnitin. Typically, you are allowed to use material from other sites, but you should not be above 20%. I'll set up to Turnitin, so when you submit it, you can see what your number is. If you're copying and you're getting things like 30–40% of stuff that's copied from other sites, then you will not get a mark for this lab, and you'll be doing another lab automatically. Done, right? There'll be no questions asked. I'll just show you what you did, and we'll move on to the next lab. So don't put yourself in that position. All right? So that's the lab. It's due a week Friday, so December 11th, 4th, 7th, 11th is when it's due. And if you're finding you're not able to get this done in time for whatever reason because you're overwhelmed with stuff, there'll be another lab that you can do, the plant lab. And then there'll be another lab after that, the STEM lab. And I'm only looking for your lab notebook, one of these labs to be completed. It's possible that you could do this lab and get a level 2 and then do another lab and get level 4. I'll take whatever the highest lab is. So there's one main lab that you must do along with the smaller labs. This is one of the main labs. So that's why it's a full lab format. All right. So hopefully that explains what you're doing. It explains how to export and import the data into Excel. If you're aiming for the highest level, you must create your own graphs. If you're aiming for, a level 3, maybe a level 4 minus at the highest, you can just take the graph directly from the Pascal probe. Right? Take a screenshot of that and just put it into your lab and explain what's going on. Right? Last point, remember that when you share your data on the website, so I'm going to take this, I'm going to get rid of this graph, but I'm going to take this information here and I'm going to put it into the shared site. So everyone, when you upload your data, you have to tell us what each run is. So you have to tell us that run 1 is 0.1 copper sulfate or 1 molar silver nitrate, or it's 30 degrees, or that it's 1.5% hydrogen peroxide. We need to know that information so that way we can do the analysis and move on. All right. Hopefully that makes sense. Send me an email if you have any questions. Thanks. Bye.